Previously on the Aruba switching story, we learned about the Edge Services platform and how Aruba switches fit into the unified infrastructure portion of ESP. We've learned about our workflow with the security camera and how we need to access a facial recognition application in the data center. So we provisioned the data center using the Aruba Fabric Composer. We've learned about data center bridging and how it can apply and benefit Aruba data center switches. Then we provision the campus to be able to plug our camera into using the various provisioning methods that we have with Aruba campus switches. We then applied dynamic segmentation and being able to securely onboard the camera into our campus. We've also learned about Power over Ethernet and some of the advanced PoE capabilities we have in AOSCX with quick PoE and always on PoE. Next, we'll hear from Matt Fern and Ruben Iglesias again, who are going to talk to us about Virtual Switching Framework, our stacking solution with Aruba switches, and some of the benefits of that. Matt and Ruben?
Thank you, Justin. So let me go ahead, and before we jump into the presentation itself, let's return to our network topology here, and we're going to be focusing on our VSF stack here that we're using for users, cameras for our facial recognition platform, as well as our PoE lighting solution. So with that, let's just go ahead and dive right in. So Virtual Switching Framework, or VSF, is a front plane stacking technology that allows network admins to combine multiple 6200 or 6300 switches into a single logical device. So what does this get you? So what this allows you to do is increase port density and resiliency while still maintaining a single point of management, regardless of the number of members that are contained within a single stack. So this means that your network admins don't have to manage 2, 3, 4, 5 different switch configurations just to expand their port count. We still maintain that single point of management. So what we do support for VSF on Aruba CX switches is 2 different topology types. Those are ring and chain topologies. A ring topology means that any member of a VSF stack has 2 different paths to any other stack member. So as you can see this little diagram here, we have links between members 1 and 2, members 2 and 3, and then we have another link combining the 2 ends, connecting the 2 ends of the ring back from member 3 to 1. So if any individual link or member in a ring topology fails, all the remaining members of the ring still have another path back to continue normal operation. A chain topology, however, means that you only have one path between any 2 stack members, which means that a failure of any member or link in the middle of a chain topology could result in splitting the stack into 2 pieces. And we'll go into more detail about what split stacks can do later on. VSF stacks use the SFP uplink ports for links between the different stack members. One of the things that we have added in the most recent release of the AOSCX operating system is the concept of reserved ports for factory default switches using our new auto stacking feature. And you can see those here in the picture here. Those are the 2 ports that are highlighted in orange. One of the benefits of VSF is it allows you to distribute uplinks and downlinks across multiple stack members using link aggregation groups or lags. And VSF uses a conductor and standby model for resiliency against failures. So VSF is great for expanding switching capacity without expanding the number of points of management that you have to worry about.
This sounds great. So how does it work?
That's a great question. So let's dive right on in. So I'm going to go ahead and log in to my stack here. I'm going to make this console a little bit bigger. So this is the conductor that is running our 3-member stack. And first, let's take a look at how our stack is actually operating here. Show VSF, simple as that. So let's start with the roles that a VSF stack member can operate in, and there are 3. Now, one thing I would like to make a quick note of here is we are in the process of updating the terminology that we use to describe some of our stack members and features on the Aruba CX platform. One of those in particular is the term master. We are in the process of replacing that with the term conductor to describe the member that is operating the stack. So when you see the word master in the command line here, know that that is the member that I'm referring to when I say the word conductor. And this is in the process of being updated in the switch software for an upcoming release. So with that out of the way, let's go ahead and start with the conductor. So this is the member of a VSF stack that actually maintains the canonical configuration and state database for the entire stack. Aruba AOS CX is a database-centric operating system. The database that maintains the configuration, status, and state information for all of your switch ports, your members, your VSF links, all of that is maintained by the conductor. So the conductor is your single point of management for the entire stack. The second role is the standby. This member synchronizes that canonical database with the conductor on a constant basis. Why does it do that? That is so that if there is a failure of the conductor, either it loses power or loses its connection to the rest of the stack, the standby member is always ready with that synchronized copy of the database to take over stack operation if the conductor were to fail. The third member type is simply the VSF member. And all this member does is switches traffic in accordance with the configuration applied by the conductor. So if you think of this like a chassis switch, the conductor and the standby are your active and standby management modules, and your VSF members are simply the line cards. They don't maintain their own state. They simply exist to provide port capacity under the control of the stack conductor to switch user and application traffic. Now, which two switches members of a stack can operate in the conductor and standby roles? So there are two special roles the stack member has to be assigned to use one of those two roles. The first is the primary switch. The primary switch is always member one. That is the member that initiates the stack build out to begin with. Under normal conditions, the primary switch is always the stack conductor. And the other is the secondary. This is user configurable. When you use one of the new auto stacking methods I'll talk about in a bit, member two is automatically assigned the secondary role, but that can be changed by an administrator once the stack is up and running. The secondary will always operate in the standby role, except under the condition of a failure of the primary switch. So those are the two switches that will operate in the conductor and standby roles. All other switches will operate only as VSF members.
By the way, Matt, I see that the status in that VSF output says no split, and then there's a line saying split detection method. Can you explain a little bit about that?
Absolutely. So I alluded to this earlier when I talked about chain topologies. A stack split is a condition that occurs when you have a failure of a member or a VSF link in the middle of a chain topology that results in your stack being divided into two pieces. Now, where this can become an issue is if a split occurs that separates the primary switch from the secondary, your conductor and your standby. What will happen is your standby will detect the loss of connection to the conductor, and it will interpret that as a loss of the conductor, and it will assume the conductor role using its synchronized copy of the database. Now, the issue there is that stack configuration has IP addresses and MAC addresses for the stack, not the individual members. So that means that once that failover occurs, you now have two stack fragments operating with the same IP addresses and MAC addresses, and any device connected upstream or downstream is now going to see duplicate IPs and MACs. That can cause severe network disruption when you have those duplicate addresses there. So we implemented a feature called split detection. What this does is it uses the management ports on the primary and secondary switches connected together in a common layer 2 broadcast domain. That can be either a common VLAN from a management switch or a direct connection between the two management ports using a single cable. This allows an alternative means for detecting whether or not a split has occurred in the stack. So if a split does occur and both the primary and secondary switches are still operating, that split detection connection will allow heartbeats to be exchanged between the two switches, allowing them to identify, yes, a split has occurred. The other portion of the stack still has an operating conductor switch. And what this will do to mitigate the effects that the disruption that can occur is it will shut down all ports except VSF links on the stack fragment containing the secondary switch. So the primary switch will continue operating with all members of its fragment normally, so you still have a single stack IP and MAC address for devices that have connections to that stack fragment. And this will continue until the failed link or the failed member recovers, in which case the members of the inactive fragment, the one with its ports shut down, will reboot automatically and rejoin the stack to resume normal operation. So that's split detection on VSF.
Well, that's all good to know. Now, how do we build a stack to begin with?
So there are a few different ways to build a stack of Aruba CX switches. Let's start with the methods that were just introduced in the AOS CX 10.7 release. So this is what we call auto stacking. I mentioned it earlier. This uses the concept of reserved VSF link ports on the 6200, 6300. So a CX 6200, 6300 switch in a factory default state running AOS CX 10.7 reserves the first two uplink ports, either ports 25 and 26, or ports 49 and 50, depending on whether it's a 24 or 48 port model. Those ports will automatically be configured as VSF links if you initiate one of the two auto stacking methods, either using the push button on the front panel of the switch or using a CLI command that we've implemented to allow you to build a stack remotely using a console connection. The third auto stacking method, which we've actually already seen in use, is zero-touch provisioning to allow the conductor of the stack to download a configuration file containing a fully provisioned VSF stack, which will, once it's downloaded and applied to the switch, will initiate the auto stacking process. So how does auto stacking actually work? What happens is when you initiate auto stacking using one of those three methods, the VSF link ports are automatically configured, either using the reserved ports for the push button and CLI command methods, or the ports configured in a downloaded ZTP configuration. Once those ports are configured, the switch will send a peer discovery protocol packet to a peer switch detected on a VSF link port. That peer switch, if it is able to join that VSF stack using a feature we call auto join, it will return a response to that peer discovery protocol packet containing its MAC address, its model number, and its auto join eligibility status. Now, what is auto join eligibility? We can actually see that here in the command that we ran on the conductor when we booted up. So auto join eligibility is based on the configuration state of that particular switch. If it's a 6200 or 6300 running 10.7 or later. A switch is auto join eligible if it is in a factory default state, or if you have run a CLI command that we provide to force auto join eligibility on a switch that is not in a factory default state. So let's take a look at this in a little more in depth. So we actually see our 3-member stack is actually down a member. We see that member 3 is not present. Let's see if we can figure out why that is. So let's take a look at our VSF links, because that's our first indication if we have a VSF link down that something is going on with that switch that's not able to join the stack. So we do show VSF link, and we actually see here we have VSF links on both members 1 and 2 that are both down. And obviously VSF member 3 is not present, so both of its links are down. Let's get a little more detail here. Show VSF link detail will actually give us the current state of this of each VSF link with a status code that can tell us why that link is not actually up at this point. So here we see those 2 links that we looked at on members 1 and 2 are both in an error state, and they have a status code of ANE. So if we look at our status code key here, we see there's ANE. Peer is not auto join eligible. There's our first indication. So, well, that may be why this member is not actually part of the stack. Let's see if we can fix that. So I have a console open to that switch, and the first thing we see here at the login prompt is this switch does not have the default 6300 host name here. It has a different host name. So that tells us that this switch may have an existing configuration on it, but let's verify that. Go ahead and log into this console here. And let's do show VSF. And here we see auto join eligibility status not eligible. But I want to find out why it's not eligible. So we add more detail to this output. And here we see auto join eligibility status and a reason here. The reason, as we suspected, configuration changes detected. So how can we resolve this? Well, one way to resolve it would be to restore the switch to a factory default state. But let's say I'm in a hurry. I want to get this stack up and running. I don't want to have to wait for the zeroization to happen. That takes an extra few minutes. I want to get this switch up and running quickly. So what I can do is, you may have noticed up here, there is a force auto join setting that is currently disabled. I can enable that. So let's go ahead and run the command VSF force auto join. What happens here is this will establish auto join eligibility even though the switch is not the factory default state. And there we can see immediately the switch reboots and joins the stack because it is already connected to a configured VSF link on an existing stack member. So that's auto join eligibility. So with that in mind, let's go ahead and take a look at another method we can use to automatically provision a stack, and that is the push button method. So I have a 3-member stack here that I'm provisioning using the push button, and watch in the top right corner, you can see pushing the LED mode button 1, 2, 3 times to put the LEDs in stacking mode. What this does is this initiates auto stacking when the switches are in a factory default state running 10.7. You saw the light turn orange, and now you see the LEDs turning flashing green and orange. A flashing green LED while the mode is set to stacking means that that member is the conductor of the stack. A flashing orange LED means that that member ID has been added to the stack configuration but is not yet fully online. In this case, that stack member is in the process of rebooting, as you can see from its console down at the bottom, to rejoin the stack. Once that member has fully joined the stack, we'll see 2 things. One is that its LED mode has synchronized with that of the stack conductor up top, and its member ID LED has changed from flashing orange to solid green. And now we see member 3's LEDs flashing orange. That means member 3 is now in the process of rebooting to join the stack and is now part of the stack configuration on the conductor. Now, once that member fully reboots and joins the stack, we'll see the same thing happen where the LED mode will synchronize with the mode on the conductor and member 2, which is the standby. And then we'll see the LEDs here will all be synchronized across all 3 members. What we would expect to see is one flashing green LED and two solid green LEDs for members 2 and 3. And there we have it. Flashing green LED means the conductor is member ID 1, and then we have members 2 and 3 operating as members of a fully provisioned stack.
What about the CLI method?
So CLI-based auto stacking actually works exactly the same as the push button method, except that it's initiated using a command from a console connection. This allows you to provision stacks remotely, which is highly useful for training or testing environments where you may not have physical access to the equipment. And to use that method from the configuration context on the switch, you simply use the command VSF start auto stacking. Now, one thing to note is this command is only usable when the switch is in a factory default state, the same as the push button method. So if you try to run this on an already configured stack, it will tell you that the stack is not, the switch is not in a factory default state and needs to be factory defaulted before you can run this command. Now, for switches running versions of AOSCX earlier than 10.7, we provide a method to build VSF stacks using the Aruba CX mobile app and the Bluetooth adapters that are included in the box with all VSF compatible CX switches, 6200s and 6300s. And this allows you to use the app to discover your stack members using both Bluetooth and connected VSF link cables to provision a stack within the app itself. And the final method we provide is to manually configure stack members using the console connections on each individual switch.
Well, that all sounds useful. So once the stack is up and running, how can we find out what it's doing?
So one of the ways to do that is to look at the switch GUI. So let's go ahead and log into the web UI. And one of the things you'll notice here is on the left-hand side of the navigation menu, we have a VSF page. So this provides some operating information about the state of the stack, which includes which member of the stack is your secondary, so that's your standby, what type of topology you're operating on, the status of split detection and the method currently in use, and the overall health status. And you have some individual member info that you can select the member you're viewing here on the left-hand side. So here we're looking at the stack conductor. We can select the standby switch here. And as I select each member, what you get here is the state of its VSF links themselves. So which interfaces are physically assigned each of those VSF links. And if we go ahead and return to our console session, we have a number of CLI commands. We've already shown show VSF and show VSF detail. We also have show VSF topology. This gives you a nice little graphical view of the topology of your stack, which includes the logical VSF link connections between each of your members. So we see link 1 on member 1 is connected to member link 1 on member 2. Link 2 on member 2 is connected to link 1 on member 3. And then the ring is closed by connecting link 2 between members 3 and 1 to close the ring. We also provide some event logs that you can take a look at the state and any transitions that occur in your stack by using command show events and looking at the VSF daemon here. So this will show any events that have occurred since the stack has booted up that have occurred to each of your stack members. So you can see you have a member that was elected standby when it was added because it's designated the secondary switch. We can see where member 3 attempted, we attempted to add member 3 to stack, but it failed to auto join, which we have recovered from. And last, we have show events for the VSF link daemon itself. And so this will show events that have occurred relating to VSF links themselves.
That seems to be a very complete way of getting the status of your VSF stack. And it's not very complex at all.
That's correct. So, and with the improvements in the AOSTX 10.7 release, we've actually made it easier than ever to get your stacks up and running without headaches. So VSF is a really great feature that allows network admins to increase their port density, improve resiliency without adding to their management workloads. And with that, I'm going to go ahead and turn it back over to Justin.
Thank you, Matt and Ruben, for explaining the benefits of VSF. On our next episode, we'll be joined by Vincent Giles and Steve Bartlett from our technical marketing engineering team, who will go over virtual switching extension and high availability, as well as resiliency in AOSCX.